Hello and welcome to lesson 4. Woo! We're going to be looking at our final lesson in the module NQ, and this is about dimensional analysis. So as you open up that Peardeck, make sure to write your name on the first slide and the date. For me, it's the 10th. It will probably be later for you, but that's okay. Notice also on the right side of my screen I have our study guide pulled up. So this, just to show you if you have not noticed, is in the module NQ folder. Right at the top, module NQ study guide. So the reason that I have this pulled up is because as we're working through dimensional analysis, it's going to be super helpful to have these unit conversions right here on the side of my screen with me. So I definitely recommend you doing that. Let's go to slide 2. What is dimensional analysis? Dimensional analysis is the process of including units of measurement when you're computing. So you are going to want to have a calculator handy during this lesson. And, you can always take notes on paper. If that's easier, just make sure you're sending me a picture of your notes or using the Peardeck notes. That works as well. So the reason that we use dimensional analysis is to convert units of measurement. So sometimes we're giving something in inches and we want to know what that equals in feet, right? Or maybe we know what something is in gallons, and we want to know what that is in ounces, right? Whenever we're converting measurements, what we're doing is dimensional analysis. So for instance, suppose that you go to Canada and you see the speed limit is 100 kilometers per hour. So how fast is that in miles per hour? We would use dimensional analysis to figure that out. Or maybe if you know that your height is 165 centimeters, but you want to know how tall you are in inches or in feet, you can use dimensional analysis to figure that out. So let's go to slide 4. Sometimes selecting the right unit involves a little more analysis than just the scale of the unit of measure. So a gallon of water can easily be expressed in cups, in pints, in liters, or in ounces. All of these units are equally valid, which means it is possible to encounter situations where the units do not match. Units of measurement can cancel, which we're going to see when we're doing the process, if the same unit is in the numerator and the denominator, okay? If when we're multiplying those fractions, if we have the same unit on the top as the bottom, they'll cancel out. A conversion factor has a numerator and a denominator that are the same quantity, but they're written in different units. And we're going to see what that looks like in a bunch of examples. So let's take a look at slide 5. This is a nice guide for converting rates using dimensional analysis. So step 1, you want to write the original rate as a fraction. So whatever you start with is going to go here, whatever that original fraction rate is. Maybe it's miles per hour, or maybe it's just centimeters, or maybe it's yards. And then you're going to determine what your conversion factor is going to be. So this whole piece here is your conversion factor. On the bottom, we're going to put the units that you started with, and on top, you're going to put the units that you want. Okay, and we do that purposefully because the units that you start with will cancel out and you're left with those units that you want as your final answer. Okay, so after you multiply by that conversion factor, you simplify and get your answer. And remember that a rate is a ratio of quantities in different units. Okay, I'm going to go to slide 6 next. Okay, so this example, we're starting with 24 inches, and we want to figure out how many feet that is. So your starting amount, here it is 24 inches. Here is our conversion factor. So notice that Inches is on the bottom. That's the units we started with. And on the top, we have the units we want. So our inches are going to cancel out. And when we multiply across, we have 24 times 1 gets us 24. And 1 times 12 gets us 12. 24 divided by 12 gets us 2. And the only unit that is left is feet. So it is 2 feet is the same as 24 inches. Okay. So that is just our first little walkthrough example. We're going to look at other problems just like this. But the key is following up at the top here, this flow, where when we're writing that conversion factor, we want to make sure we're putting the units that we started with in the denominator. So that's why we had inches down here. And then the units that we want on top in the foot. And notice in this conversion factor, this really just equals 1. 1 foot is the same as 12 inches, right? That's the ratio. Units are different, but it's the exact same measurement. 1 foot is 12 inches. Let's look at slide 7 and do an example. So we have 100 kilometers per hour equals how many miles per hour? So following our flow up top here, first thing we're going to do is what we start with. So we're starting with 100 kilometers per means divided. We have 1 hour. 100 kilometers per hour. And we want to multiply that by our conversion factor. So we're starting with kilometers, and we want to get it into miles. Okay? So we look at our conversion chart over on the right, and I'm looking for miles and kilometers. So I'm looking, and I see that 1 kilometer is 0.621 miles. So 1 kilometer is 0.621 miles. And then I'm going to put my equal sign, and we're going to figure out our answer. Kilometer and kilometer cancel out. So on top we have 100 times 0.621. And we also have meters on there. And that is being, that's really divided by. On our bottom, we have 1 times 1, which is 1, and we're left with hours. Right? So 100 times 0.621 gets us 62.1, and then this is miles per hour. So that is our final answer, 62.1. So we just multiplied these numbers across, kept that unit of miles, and kept that unit of hours, multiplied 1 by 1, stays as 1 for the hours. So 62.1 miles per 1 hour. And that's our first one. Yay! When you're all set, you can go to slide 8, pause if you need to, get whatever you need here, my friends. And we'll look at number 8 together. 165 centimeters is how many inches? Okay, so we're starting with 165 centimeters. Great. We want to convert it, so we're going to multiply it by a conversion factor. That's this part. Oops. That's this part here that we're figuring out right now. So the units that we started with are centimeters, and the units that we want are inches. So I'm going to look over here at my chart, and I'm looking for centimeters and inches. And I'm looking, and here I see this, that 1 inch is the same as 2.54 centimeters. And then we're going to multiply across. Centimeters and centimeters cancel. On the top we have 165 times 1 equals 165 inches. And on the bottom we have 2.54. So now we want to do just some dividing. I'll get my calculator. And I'm going to do 165 divided by 2.54. And I get this value of 64.96 inches. So there's our answer, 64.96. So we canceled out those centimeters and then we just multiplied straight across and then divided to get our solution. Beautiful. Slide 9 when you are ready. We have 2 more practice problems here that we're going to do. 165 centimeters is how many feet? So this one, we might have to do 2 conversion factors. Oh no, oh, we have this one here. We can use this. 1 foot is 30.48 centimeters. So we're starting with our 165 centimeters. And we're going to multiply that by a conversion factor. We want to start with our centimeters, and we want to, in the end, we want feet. So the units that we started with, centimeters, go in the bottom. The units that we want go up top. 1 foot is 30.48 centimeters. So when we multiply across, our centimeter units cancel. And we're left with 165 times 1 gets us 165 feet, divided by 30.48. 165 divided by 30.48 gets us 5.41 feet. Beautiful. Get everything you need here. Hopefully this is starting to be in flow, but we're going to do more practice throughout the week, so no worries. However you're feeling is perfect. And we'll go to slide 10. This is 32 feet per second, and then we want it to meters per minute. So we're doing 2 here. First we want to do feet to meters, and then we're going to want to do seconds to minutes. So let's start off with our starting amount, which is 32 feet per 1 second. And we're going to multiply this by 2 conversion factors. So the first one is going to change feet to meters. So feet is what we started with, what we're getting rid of. Meters is what we want. If we look at our sheet here, feet to meters, so 1 meter is 3.281 feet. So first, if we multiply this out, cancel out the feet, we're left with 32 meters per, and then down at the bottom we have 3.281 seconds. So if we simplify that, 32 divided by 3.281 gets us 9.75 meters per second. Beautiful. And now we want to take that, so So I'm going to draw a little line here. Because now we're going to take that information